Hello and welcome everyone. I'll be explaining this problem called maximum cost permutation. Uh, hmm. So in this problem, you're going to be given an array uh, and you have to output something which is called the maximum possible cost of the resulting permutation. So let's just first talk about the what do we exactly mean by the term cost, and because that's important in order to understand the solutions of the problem. So let's say, or let's imagine, I have an array, or should I say I have a permutation, 5 elements, and the elements would look something like that. Let's say 1 is here, 5 is here, and it's 4, 3, 2. Yeah, got it. So let's say I have a permutation, an array of 5 elements, and I'm asked what would be the cost according to the problem that it said, and how are we actually going to be able to calculate the cost? The cost, um, you see, in the problem said about, okay, so um, the cost of a permutation as the minimum length of its contiguous subsegment that needs to be sorted in order to uh, sort the entire permutation. So um, our goal would be to sort the permutation, the initial permutation, but it said that what is the minimum possible subarray or subsequence, not subsequence actually, minimum possible subarray that I need to sort in order to sort the array. Now, if you look at this permutation, you would quickly notice that this is the part that we actually need to sort. This is the minimum possible subarray that is required in order to sort. If this is the minimum possible subarray, if you sort it like that, then what happens? The the actual array gets sorted, right? You could have taken a subarray of the whole element, but that wouldn't be the smallest possible subarray. But you sort such that the whole array is sorted. So that's the thing. Um, Now, this part needs to be as maximum as possible in the final output. But the point that I'm trying to make is that this is what it means when we try to find out the cost of this for this particular example. So what would be the answer here for this array? It would be the length of 3 length of subarray. Now that's the minimum possible subarray length uh, according to the definition of the thing that was said. Now our uh, our target would be to maximize this number given a certain condition, initial condition of the array. What is that certain initial condition? Let's take a look at that. Now we go into the the problem definition actually, and this is the definition here. Let's see that the initial array that you're gonna get. Okay, you are gonna get a set of numbers as an array, but some of the values are going to be 0. Some of the values initially, for example, let's take this example. Okay, so it's going to be 5, 5, so it's going to be 5 values, 1, 0, 4, 0, 5, I guess. So it is also said that whatever non-zero value that's going to be given inside the array, initial array, it will always be unique. So no duplicate values of non-zero values. But there will be values which would refer to 0, and they can be multiple numbers. Now, what you have to do is build such a permutation from this thing. You have to build such a permutation such that when you calculate the cost that I just mentioned at the very beginning, it would be as maximum as possible. Okay, so how did we calculate the cost? We calculated the cost by identifying what is the smallest possible subarray that needs to be sorted in order to sort the whole permutation, right? I mentioned about it. But now our goal is to find out a certain permutation of array such that when we calculate the final cost, it would be as maximum as possible. Now, think about it. How do we change the values of these 0 such that it gives me the optimal result? Now, there's a greedy, I could actually think about this as a greedy solution. Now, my intuition was that, okay, what if the array, well, I mean, my intuition was something like that. That I was thinking, okay, what could be the maximum possible cost? What could be the maximum possible cost? Let's say 5, 4. I was actually going through some examples, and then I came up with this. Uh, Take a look at this array now. 5, 4, 3, 2, 1. What if the what will be the case, or what will be the cost for this array? Now, this array is actually descending order, right? It's actually in descending order. Now, think about this array. What do you get? What would be the cost? Like we mentioned before, if we calculate this, the cost would be 5, or I could say the length of the whole array. Now, uh, why did it happen? Because there's no other way to find out other small number of subarrays such that if you sort them, you get the whole permutation sorted. So that's the so if you descend if the initial array or the permutation is as a whole in the descending order, then there's no other way that you could find out such that you get um, other answers. The answer would always be the length of the array. So based on this assumption that this is the way that I could get the maximum cost, now I need to make this initial array like that. Now I know that it's not going to be exactly the same, but my intention would be to follow this baseline here. So what I did was something like that. Okay, this is my baseline array. I want it to be something like that. Not equal, not exactly the same, but something very, very similar. Now, what I did, my goal was to just, replace these 0 values. Now, how can I do that? I will simply go through what would it look like if it was a descending order. And I did. I went through, okay, this is the value of 5. Now, is 5 already existing in the initial array? Okay, if it is already existing, then I cannot add here, right? I cannot add and fill up this 0 because it's a permutation we're talking about. We cannot just add this thing. So 5 we're not going to add. What about 4? Does it already exist in the initial array? Yes, it is. So I cannot add it to add this value to. Now what about 3? Now 3 is not inside this anywhere here, but according to my best possible answer, 3 should be uh, in the in this position at the earliest of 0 where the 0 value is. Why? Because I'm trying to make it look like the descending order. Of course, it's not going to be exactly the same because some of the values are already being placed, but my job is to just fill out the 0 values, and I'm going to do that in such a way that it follows this baseline example. Similarly, I'll check 2. Does 2 exist? No, it does not exist. So add the 2. Now, when you do that, what happens? What's the final array that you get? I would get something like, I guess 1. What was the array? 10405. Okay, 10405. And I said 5, 4, 3, 2, 1. So 3 was here, so that's going to be 3, and that's going to be 2. So this was my final array. This is 3, and this is going to be 2. Now, I will simply do the exact thing that I mentioned at the very beginning. I'm going to try to find out the cost. How am I going to find out the cost? What's the best way to do that? What I did was I used a two-pointer approach to find out exactly which position from the left is not exactly the same as its position, right? Think about it. This is the current position, right? Each and every element. And I was just, going through the loop. Okay, this is where it breaks. I say, then break it and break it. You see what I'm trying to do? I'm trying to actually calculate using a two-pointer, and calculating whether the positions actually match with the value, because this is exactly how I can shrink it down to the smallest subarray, right? Like that, from the very beginning and from the very last. And I can say that, okay, this is the point I have to make a change. And that's exactly what's happening. What's the length of this thing? 1, 2, 3. Let's take a look at the answer, whether it's 3 or not. If it's 3, then definitely our answer is correct. And there you go. The answer is 3. So that's how we would be solving this problem. Let's take a look at the code section here. I think it will be much more easier. Okay, so this is the code section. You see, I took the values. This is the part where I actually covered the value 0 with the value that is required. The descending order, the base example that I am taking each and every value from there and putting it wherever the value is 0. So okay, so this is exactly what's happening, and then actually updating the initial input, and finally calculating the cost the way I mentioned at the very beginning, using a two-pointer approach. Now here, wherever the position breaks, you break it down and then you calculate the length. So I hope I made you understand. Thank you so much for watching this video. Thank you very much.